Hi guys, this is Anuj, and part 2 of this playlist on microservices. We will be talking about service discovery. Service discovery is the process of automatically detecting devices and services on a particular network. This is one of the fundamental concepts of microservice architecture, and knowing this is super useful. Let's see what it is. Assume that we have a client who wants to communicate with a service, let's say service number 2. In order to make a request to service 2, the client needs to know the network location, that is the IP address and the port of the service instance. Now, for the traditional applications which are running on physical hardware, the network locations of these services are relatively static, and our code can read the network info from a configuration file. But in a modern and cloud-based deployments, these instances have dynamically assigned IP addresses. Moreover, the set of instances changes dynamically because of things like auto-scaling, failures, upgrades, etc. Because of this, the client's code need to use a much more complex service discovery mechanism. Now, that's a lot of overhead on the client side, which may make the application slower. To avoid all of this and to decouple the configuration logic, we introduce a middleware known as Service Registry, which is a database populated with information on how to dispatch requests to microservice instances. It essentially acts like a router containing the address mappings of these microservices. The way the communication will now take place is the client would be sending a message, let's say find service 2, to this service registry, and it will in turn return the network information of that particular service. Then the client, knowing this info, can directly communicate with the desired service. The service registry can also act as a load balancer. So suppose that we have multiple instances of service 2 running on different ports, say 8080, 8081 and so on. Now instead of redirecting all the requests to port 8080, we can make some intelligent decisions and redirect these requests to all of these instances such that none of the instance will be handling more load than it is intended to. This process of distributing all the requests evenly among all the instances is called load balancing, and we'll be talking more about it later. Now, there are two types of service discovery patterns which can be used. The one which we just discussed is called the client-side service discovery, where the client is responsible for determining the network locations of available service instances and distributing the load among them. The benefit of this pattern is that it is a relatively straightforward, and except for the service registry, there is no other moving parts. A very good example of this pattern is the Netflix OSS, which if you want to know more about it, you can read the description where I will point a link to it. The other service discovery pattern is a server-side discovery pattern. In this, the client sends the message it wants to communicate to the service registry, and from here forth, it is the service registry's responsibility to communicate with desired service and provide the response back to the client. This pattern also has several benefits and drawbacks. One great benefit is that all the details of the discovery are abstracted away from the client. Client simply makes a request to the service registry. Examples of this pattern are AWS Elastic Load Balancer and Nginx Plus, which is basically a HTTP server and a load balancer which can be used as server-side discovery. Now, the advantages of these patterns is that all the extra configuration settings have been decoupled from client application, and hence this makes the app lighter and more performant. It also increases the scalability of the entire system, as now when a new service has been added, the client application remains intact and no changes need to be done there. Only the service registry need to be updated with addresses of these new services. Also, with the service registry acting as a load balancer, we can evenly distribute all the requests coming from client to all the instances running, and hence none of the instances will be handling much more load than it is intended to. So that is all for this concept video. In the next video, we will be talking about how to build from scratch a service registry using Node.js and Express. Also, if you like this video, press like icon and hit the subscribe button if you want to get notifications of new videos like this. And if you have any questions or feedback, please mention them in the comments. See you next time.